Okay, welcome to your lesson on air pressure. First thing I'd like you to do is make a new notebook page and title it air pressure, and then be sure to go to your table of contents and label that as air pressure. Our guiding question for this lesson, and you're going to write this on the top of your notebook page, is what is air pressure and what causes it to change? Big focus here today is going to be what causes air pressure to change, and we're going to briefly define what air pressure is before we get started on why it changes. Okay, after you've written your guiding question, I want you to write the word of the day, which is air pressure. And air pressure is simply the amount of air that is pushing down on you. And gravity is actually what's holding our atmosphere in place around our Earth. And so all those air molecules that are surrounding the Earth get pulled down by gravity. And that kind of pushing down force is measured as an air pressure. So that's our word of the day, air pressure. Go ahead and copy that down. If you need to pause the video to get that copied down, go for it. Okay, so under your word of the day, we're going to set up our notebook page to look like Cornell Notes. Notice this time, I'm not going to give you any of the main headings. I'm going to let you fill those in yourself today. And just a reminder, you're not done with Cornell Notes until you've written your summary, and you've written about 3 to 5 questions that can be answered with the notes that you take over here. These are simple, sometimes simple questions, or maybe some compare and contrast questions that you need to ask over here. Okay. So go ahead and pause this video if you need some time to set this up. Okay, so I'm going to move on. Our first topic is what the molecules look like in low pressure. So this has been kind of a theme we've had all year whenever we've had to talk about molecules, is using these dots as particles. And so these dots are going to represent our air molecules in our atmosphere. Okay, and just like when we learned about low density, we had our molecules really far apart. And so this is a picture of what air looks like in low pressure. Okay, the molecules are far apart and the air is less dense. This is what we would see maybe at the top of our atmosphere before we go into the exosphere. As we get away from the Earth, we know our air pressure gets less and less and less, and they become less dense. Okay. Our molecules in high pressure are going to be closer together. Notice they are still a gas though. These molecules are not arranged in organized matter. They're still moving around each other. They're still fairly spread apart from each other, but they're closer together. And in this case, the air is more dense. So the more crowded they are together, the higher the pressure. So that's our first part of our guiding question, is what do the molecules look like in low pressure and high pressure? High pressure just means more air molecules closer together. Okay. If you haven't been drawing these pictures, please make sure you're drawing these pictures in your notes. These pictures actually tell you more than the words are. All right, so our next part of our guiding question is how to change air pressure. So there's a couple different ways we can change air pressure. I'm going to go with this first method, and it doesn't actually work in our atmosphere, but I want to give you kind of an idea of what we need to do to change air pressure, is that we need to change the molecules from being really, really spread apart to being closer together. So the more spread apart they are, there's low pressure, and we can squeeze them together, we can get a higher pressure. And this can be done many different ways. One way is if you have a container, what we're going to call a closed system, and you make it smaller. This will increase the pressure by making the molecules more dense. So you just basically take a box and you squeeze it together and make a smaller box. And those air molecules are going to get smushed together and become more dense, and the pressure is going to increase. This doesn't work though. And the atmosphere is not a closed system, it's an open system. okay, because we can have things escape into space. So this method doesn't work when describing air pressure. So we need a different method to help us change our air pressure. Okay. So another method, and this is the one that works well in the atmosphere, is to increase the temperature. And in our open system, I should change that to system, we'll decrease the air pressure. The air molecules spread out when heated and become less dense. We know the air molecules spread out when heated when we learned about our states of matter. When things change from a solid liquid to a gas, we know that these air molecules are getting further and further apart. So in cold air, they're going to be really close together, and then when we warm up that air, they're going to want to get further and further apart from each other, and so they're going to become less dense. So this is what happens in the atmosphere, is that when we have cold air, we're going to have high air pressure, and when we have warm air, we're going to have low air pressure. And this is shown on this diagram here. So the relationship between air temperature and pressure is what you need to remember is that they're opposites. If we have higher temperatures, we have lower air pressure. If we have lower temperatures, we're going to have higher air pressure. This is what we call an inverse relationship. Okay, you want to think of them as opposites. Okay, a lot of times we want to think, oh, when one goes up, the other goes up. That's not true for air pressure and temperature. When one goes up, the other goes down. When one goes down, the other goes up. Okay, and that's shown again here in our diagrams of warm and cold. You probably don't need to draw these pictures again because you have it on your other slide. But maybe add these words, molecules are close together and molecules are far apart. Okay, so what we're working towards here and what you're going to learn in your next lesson is what causes wind to blow. And basically, changes in air pressure is what causes the movement of air. And so air with a high pressure moves to an area with low pressure. So this is an area of high pressure, and they're really close together. You can kind of think of this again with a hallway. So you're in your hallway, it's really, really crowded, you're in that stairwell, you're trying to get to your buses, and all you want to do is get to your bus and spread out. So this is the really crowded school hallway, and you want to get more spread out, maybe get outside those doors where you can spread out a little bit more. Molecules want to do the same thing. Air pressure, if there's tight air pressure over here, and there's a space where they can get to, they're going to want to spread out. So air moves from an area of high pressure to low pressure. And the molecules basically want to be equally spaced out. They don't want to have any friends next to them that are more spread out than they are. Another way to remember this high to low idea is kind of think of you have a friend named Low. You usually don't have a friend named High. You have a friend named Low. And you want to say hi to your friend Low. You're not going to say low high. You're going to say hi low. Okay? So if you need a trick to remember, you're going to say hi low to help you remember differences between high and low. Okay, a few more things I want you to do before you're done with this and you get credit for watching this video. Next thing I want you to do is I want you to watch 2 videos linked to this assignment in Schoology. Be prepared to explain how changes in air pressure cause these phenomenons. Okay, so there's going to be 2 videos. Video number 1 is egg in a bottle, and video number 2 is going to be can crushing. And you also need to finish your Cornell notes. Remember, finishing Cornell notes is to write 3 to 4 possible test questions that can be answered with your notes and write a summary. Once you're done, you're going to get this checked off, your notes checked off, and then also be prepared to answer and discuss these 2 videos. You can find those videos in Schoology. We're in level 6, the subtropics, and you are in, so let's just show you how to get to level 6, the subtropics, and we are in lesson 6.1, and the 2 videos are right here. Okay. Good luck watching the videos, and flag me over when you are ready to get credit for this quest. Thank you.